Okay, I'm back again and finishing up this iPhone 6 with long screw damage. I've repaired all the traces and it does now boot with image, and what I found is that it had no touch. So I flipped it over, pulled the sticker, found some corrosion, some signs of liquid damage, which I've mostly cleaned away. But then I kind of put a stop to it um, because I needed to call the customer and discuss how they want to go ahead with this. So the guy said really all he's worried about is getting his data, which is great. That means that all of my work is not wasted. I can continue getting this working well enough to get data off of it, but I don't have to be concerned about any secondary issues due to the water damage. So I have done one thing before I started streaming. When I left off, I had lifted Cumulus to see if there was any corrosion under it, and there wasn't, so I placed it back. And then I just reflowed Mason because it didn't look like there was corrosion under it, and that still didn't have touch. So the part that you're not going to be able to see that I've already done is I lifted off Mason to check and see if there was corrosion under it. If there was, that's where I was going to start streaming, but there wasn't, so I put it back on, and now touch works. So you're just going to have to trust me that just lifting Mason and putting it back down fixed touch. But now I've got a new problem because I've had so much heat in this area, which is directly on the other side of the backlight driver. Now I have no backlight. So backlight is not necessary for data, but you know, I didn't quote the customer for data. He's still just paying the standard long screw damage fee, which is cheaper than data recovery. So I'm not planning on extracting his data for him. I'm just going to get it into a stable working state so that he can get his own data. So because of that, I'm going to have to fix backlight because I can't expect a customer to deal with no backlight, even though it's really not that hard. But this backlight problem, especially on the 6 after touch repair, is I would say it's fairly common. And what happens is that this underfill around and under the backlight driver tends to expand when it gets hot, and that kind of pushes the chip up from the bottom, and it also weakens the solder ball joints to the chip. So what happens is that some of them just break connection. They break cleanly off at the chip, so the ball's still stuck to the board, and you know, if I was to apply some pressure, I could probably get backlight working, but in order to send this back, I'm going to need to lift that backlight driver and clean all the underfill out and then put it back down. A lot of times I can get the driver the driver off without damaging it, and then just put the same one back down. So that's what I'm going to try. If that doesn't work, then I guess I'm going to put a new backlight driver. So I think for this, I'm going to try doing this on the old hot plate. I think that'll make it a lot easier to pick away this underfill. So when I use the hot plate on my station at home, I have to switch out. It doesn't really work well with the Barlow lens, so I've got to take this Barlow lens off. All right, there we go. All right, turn the hot plate on, let that warm up, and I'm just gonna keep it on there for while I pick away the underfill, and then I'm gonna take it off when I want to actually use hot air, because I'm not sure how much CPU is gonna like being on the hot plate while I'm using hot air right next to it. So I'm gonna go with the technique that I know always works, which is just quarter on the CPU and hot air with no hot plate.
Amelia, make sure that you have all of the stuff that you printed out size right, so it takes up like it looks good on your board.
So the underfill is taking a little bit of the black coating off the top of the chip, but that's not really a big deal as long as the actual material of the chip itself is not damaged. It's really, it doesn't matter. The only real problem is now, oh, there we go. Crack the chip. All right, that's done. This little nick right there, that is enough to make this chip not work. So I'm just going to go with putting a new backlight driver on. Tried to save $2, but looks like I'm going to have to pay for that. All right, so now I got to put the Barlow lens back on. Okay. All right. Come on, get out of there, guy. There we go. Let's have a look. See, you can clearly see there's a few pads on that backlight driver that are oxidized. So that's the reason why this has no backlight. We'll just clean up the pads and slap a new one on there, and that should be done. And then I have an iPhone 6 that is not charging on deck to fix next. Tweezer tips are oxidized again, so I'm just going to clean those off. All right, that looks good. I think that'll work. Now I got to dig out the backlight drivers. So I've gotten rid of the camera on my hands because it's really just it drives me nuts. It makes it so hard to work. Maurice in chat says that he just got the 0.75 Barlow lens and really likes the compromise between the 0.5 and the 1. I know Jessa ordered a bunch of the 0.75 Barlow lenses and has them for sale through our supply store. I haven't really gotten a chance to check them out myself. I guess I could, but I'm used to the 0.5, so I'm very much believe if it ain't broke, don't fix it. So I haven't really given them a try. Oh, old mom in the chat asks if I'm using the exhaust. Yeah, totally. Can't you hear it? Of course I'm using the fume extractor. You think I'm crazy? Come on, backlight driver. Settle down. Go to your home. It's starting to go. Come on, you can do it. There you go. Not quite done yet. Come on. Maybe a little bit of underfill keeping him from getting all the way down. All right, let's add a little bit more flux and see if we can get him situated right where I want him. Come on, you can do it. Guess I did not clean enough of the underfill out. Picked it all away, but I didn't dig out all the chunks, and now they're causing me problems. All right, one more time. It's gonna work this time. Come on, guy. There, I think he's good now. So the lesson there is don't rush things and make sure that you get all of the underfill out of the area. So those loose little bits can cause the chip to not settle. All right, let's see. Just going to cool the board off a little bit and see if we can get this booted up with working touch and image. Let's see what's going on in chat. Oh yeah, the Barlow lens requiring you to sit high. So I sit on a stool and I have a workbench that I built that's about 4 feet high. I don't know, a little more than 4 feet high, maybe. I know during class for the students, we recommend that they try out the Barlow lens and try soldering with and without it just to figure out what you like better. And for a lot of people, their torso is not long enough for them to comfortably look through with the 0.5 Barlow lens while they're sitting on the chairs that we have there. All right. Let's see some backlight, image, and touch. Come on. Okay, so looks like that backlight driver placement is no bueno. We'll try this again. And there's the problem. Some solder came out from the coil and bridged to that ball right there. So it wasn't a problem with underfill. It was a problem with the bridge. Okay, one more try. This time it's going to work. Come on, you can do it. Come on, little backlight driver. Just slide over to the right a little bit. I know you want to. Ooh, it's getting hot on my hands. I think he needs a little bit more flux before he's going to settle just right. Yeah, I think my hot air does need to be calibrated. I've suspected that over the past couple of days. It seems like the temperature I'm used to running at doesn't quite get the job done the way I'm used to, so bump it up 10 degrees, see what happens. There we go. That's looking a little better. All right. That's what I want. All right. That should be the end of that. And I can move on to the charging problem. Hopefully. Fingers crossed. Just going to set that board in front of the fume extractor for a second to cool it down a little. Maurice says, I don't know why, but lately I've had to reball everything 3 times before I get a good set of balls on the chip. Really frustrating. Tried different stencils and so on. Yeah, I feel you, Maurice. I I get really frustrated when I reball too. My personal solution is, even though it takes longer to do, I reball with balls rather than paste. And it takes longer to make sure that a ball is in every hole and only 1 ball per hole. But I find that even with that extra work, it's still quicker than reballing with paste 5 times in a row and still having it not work. All right, so it looks like I did not connect the LCD. Brilliant. Okay, there we go. All right, we got Apple logo. Let's see if I can get that on the screen. There we go. So what I'm looking for is for this to fully boot up and have working touch. And then I'm going to call this good, because at this point, the customer is only interested in data. So I know it has good USB communication. So all that's left is to make sure that it has working image with backlight and working touch, and then it can go back. And there we go. We got working touch. All right. So that one is done. So just to recap, this was long screw damage, fixed all the traces, had to go down in the 3rd layer for this trace, then found some liquid damage on the back, got approval for data only, lifted Cumulus, found no corrosion, placed it back, lifted Mason, found no corrosion, placed it back. Then after that, touch worked, but I had no backlight. So I changed backlight driver, and now I have working backlight, image, and touch, and this one is good to go. So next up is an iPhone 6 that is not charging. So of course the first suspect for this is going to be Tristar. I'm just going to check really quick just to see what it's doing on DC power supply. A lot of times when Tristar fails, booting the board from DC power supply ends up pulling like 70 to 90 milliamps. Sometimes it'll boot up just fine, but sometimes it won't. And it looks like I'm just stuck at 80 milliamps. So that definitely makes me strongly lean towards Tristar being the problem. So we're going to go ahead and change that. Oh. Get that cable out of the way. I'm just going to heat up this area just a little bit so that I can pick the underfill away a little easier. It's not necessary to take the underfill off the top, but I find that the heat transfers through the chip and melts the balls a little bit better if you pick that away first. And I like to pick away this underfill here so I don't end up pulling up these little caps when I lift the chip. All right, I think that's good enough. Now, I used to put a quarter on NAND when I would do this job, but I've found that NAND it's a lot tougher than you might think, and the quarter really, rather than helping to protect the NAND, it really just makes the job take longer because it pulls so much heat out of the board, and this is already an area of the board that has a very high thermal mass, so it takes more heat to remove Tristar than most other chips to begin with, and then when you go adding a quarter into the mix, it just takes even longer. So I no longer protect the NAND. So I'm just grabbing the chip and just lightly closing on it and trying to give it a little twist. And I'm not trying to like pry it off. I'm just trying to twist it, see if I get movement. If I do, then I know it's ready to come off. This is how you can avoid pulling pads when you're removing chips. You don't ever want to just like try and pull the chip straight off. You want to twist or wiggle it, see some movement first. That way you know the balls under it are melted. All right, so I'm going to go up 10 more degrees on my hot air because this chip normally takes longer than most others, but it's taking longer than I want it to now. Oh, uh-oh. Get back over there. It's getting close. There we go. Just picking away the remnants of underfill in the area. All right, ready for a new one. Just looking for the chip to settle into its spot. Starting to. I'll just give it a little nudge. Nope. The nudge is dangerous, but really helpful. As if the chip is in place and good to go, you'll see that it snaps right back into place. If it doesn't, then you know it needs more time, but you're nudging fractions of a millimeter, so it's easy to go too far and cause problems. So there, you see now I touch it and it snaps right back into place. Oh. There. That's what I want to see. Alright, so that should be good. Just put it in front of the fume extractor, cool it off a little bit, and then I'll hook it up and see if it is charging. Before it was pulling 10 milliamps when I would try to charge it through the USB amp meter. It would pull 10 milliamps, and on DC power supply it would pull 80 milliamps. So hopefully we'll have that fixed. Let's see. Maurice says, okay, I should really try that with pre-made balls. Thanks for the tip. Yeah, highly recommend. I keep 0.3, 0.25, and 0.2 balls in stock at all times. For iPhones, if you're not dealing with like Samsung stuff, you probably only need the 0.2 and 0.25. I really only use the 0.3 on Samsungs. Let's see. eDigitCom says, why does it take longer to remove? So I did talk about this a bit earlier, but in case you missed it, it's due to the thermal mass in the area. There's all of this is ground, and it's all connected to other layers of ground within the board through what they call thermal vias, vertical connections between one layer and the next in the board. So that's why this Tristar takes so much longer. Other Tristars in other phones, you find that they're surrounded with all these different components and very densely populated, but this one is surrounded by a bunch of ground, so the heat just gets pulled away really quickly. So that's why it always takes a little longer. So I don't have a camera on my USB amp meter, so you're just going to have to trust me whether or not this is charging, but I can at least show that it is booting up off of DC power supply first. So try that first. Go ahead and prompt to boot. And it looks like we're just sitting here at 150 milliamps. So that is no good. Oh, yeah, now you're going. Now you're fluctuating. So what's going on? You have no image. Did I not plug the LCD in very good? Yeah, this test LCD is getting a little bananaed. Get that plugged in real good. All right. Try it again. And there we go. We got Apple logo. So that convinces me that it's fixed, but I will also just take the LCD off, hook up a battery, and just a battery and dock, and check DC power, or USB amp meter says it's pulling 1.25 amps, so it is charging, so I'm happy with that. I'm going to say this one's solved. I'm going to take a little break and then move on. I got quite a few things to work on today. I'm going to try to stream most of it, so I'll be back later. Thanks. I always appreciate you guys watching, keeping me company on stream. Have a good one. I'll see you later.